Welcome to solverfy.
Hello, my name is Margaret, and today I'm going to be answering a question from Chapter 8 from the textbook Chemistry, the nature. I'm sorry, the nature of, or the molecular nature of matter and change, the 7th edition. The question we're looking at is number 28. And it's asking us for partial or valence level orbital diagrams and the condensed ground state electron configuration for several different elements. So let's get to it. The first thing we're going to do is we're going to start off with the electron configurations because it will be easier for us to fill in the orbital diagrams from there. So electron configs. All right, so starting with barium, barium is in the 6th row in the S block next to cesium. And so going back to its most recent noble gas, that would be xenon. So we'll put xenon in brackets because it's asking for the condensed, so we don't have to write everything out. And then from there, we will write out the electron configuration as we normally would. So 6. So 1, 2, 3, 4, 5. Yep, double checking 6, S2. And that's all for that one. Next, we'll move on to cobalt, which is in the middle of the 3rd row of the D block. And so its most recent noble gas is argon. So argon, followed by 4s2. And then 3d, 1, 2, 3, 4, 5, 6, 7, 3d7. Now, lastly, we have silver. And the reason I have an asterisk next to silver was to remind me to make sure that you guys understand the special rules that apply to the elements in the columns that silver, copper, gold, chromium, molybdenum, tungsten fall in. These are elements whose electron configurations and orbitals don't fill quite the same as everybody else's. And that is because of how their orbitals are. They end up pairing, they don't end up following the pairing principles quite the same. And that's because by defying the rules slightly, they end up with a lower energy, and therefore it's more favorable. So going back and writing out the argon, writing the electron configuration out, we circle back around and we see that argon, the last noble gas for it is actually krypton. And then from there, we have 5s2, and then 4d9. Now that's how, according to the rules, we know it would be written, okay? Now, because the D block is so close to being filled, it will steal an electron from the filled and paired 5s2 in order to be completely filled. And it's actually krypton 5s1 4d10. And that is because the unpaired s electron is much lower in energy than the unpaired d electron that's over in here. And so it ends up taking this electron so that way it can be in a lower energy state. So that is why this is not true. Okay, the d block, because the d orbitals are just so much higher in energy than the s orbitals, they all want to be paired. And so they are willing to steal electrons from other places in order to make that happen. So now that we have those done, we can move on to the valence. Diagrams. All right. So how to do these? We essentially are just going to take the row that element is in, and we're going to write all the orbitals out, and then we use the electrons that are not grouped into the brackets, and we're going to fill the orbitals in. So for barium, we come down here, and this one's a bit of a doozy. So we have 6s, and then we have 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. There we go, 7. So then we have 4f, and then we have 1, 2, 3, 4, 5. Yes, and here we have 5d, and then we finally have 6p. There we go. Right? Also, we can write these 2 electrons right here. But we did it. Right? And the F, right, has 14 electrons, so it has 7 orbitals because all the electrons can pair off. And so if the D is 1 energy level lower in the same row, then the F block in the same row will be 2 energy levels lower. That's why that one's 4F. Okay? So now that one's done, we can move on to cobalt, which will be much simpler. Right? And so we have 4s, right? 1, 2, 3, 4, 3d, and then finally 4p. Then we have 1, 2, and then everybody's going to get an electron first. So 1, 2, 3, 4, 5, and then come back and pair off 6, 7. And then to come back down to do silver, we have 5s, and then, ooh, that's lopsided. Okay, so 4d, and then 5p. 1, 2, 3, 4. Then that one. And so just so you can see it, I'll show you. So normally we would go 1, 2, 3, 4, 5, 6, 7. Ooh, yep. So 1, 2, 3, 4, 5, right, go into the d orbitals, and then they start to pair off. 1, 2, 3, 4, right? But this guy by himself is not so happy. So we come back and we say, you don't get to live here anymore. And he comes back and he'll pair off there. So the D block is filled, even if it's at the expense of the S block. So I hope this cleared up your understanding of how to fill orbitals, how to draw them out, electron configurations, and in particular, I hope that the explanation of why silver, along